What's up guys? So today in this video we will talk about how Catalyst Optimizer chooses join strategy in Databricks, and then we will see a practical demo in Databricks. So let's get started. So I'm gonna explain to you regarding how Catalyst Optimizer does this join strategy through the flowchart. So let's say if we are using equi join would means doing a equal join, which would mean, let's say for example, my let's say a is one table, then a dot order id is equals to b dot order id. So this equal would mean equi join. So let's say my a is a small table. Small table would mean anything less than 10 MB, and then B is my big table. Let's say greater than 1 GB. So if we do a equi-join which is equal, then if one is my small table, let's say A is my small table, then broadcast has join is executed, and if it is not, then sort merge join is executed. So Catalyst Optimizer internally uh, uses a broadcast hash join if one is a small table and another is a big table. If not, it uses sort merge join by default. So this is in case of equi join. So let's say if we don't have a equi join, let's say if this operator is not equals to, which means this is not a equi-join, and if my one table is small, then what happens is broadcast nested loop join is internally being executed. And also if the both tables are big and it is not a equi-join, then Cartesian product is executed internally through Catalyst Optimizer. If we don't see both cases, then broadcast nested loop join is executed, and this is in a danger zone of having OOM, out of memory issue. So we would prefer to do equi join when possible, and try to avoid non equi join. So if we look at the execution, the time complexity of broadcast hash join, so it takes around on time. If we look for short merge join, it takes around on log n. And if we look at broadcast nested loop join, it takes around on n times m, and this is the worst. The Cartesian product is the worst, and it takes nearly o n times n m, and this would cause out of memory issue. So I will explain to you more in Databricks notebook. So let's jump to notebook. Let's start with broadcast hash join. So in simple term, broadcast hash join involves replicating the smaller dataset, or maybe a default size would be less than 10 MB, across all the nodes in the cluster, allowing each node to perform the join locally without the need of data shuffling across the network. So broadcast join copies the dataset across all the nodes so that the shuffling would not happen, and that would reduce the networking cost. So it would copy in all nodes so that the expensive operation like shuffling would not happen. So let's see that in a practical example. So let's say this is my table, and this table contains around 5 billion records, and this is another table, and then it contains around 1986. It's a very small file. So when we do a join with let's say 1 billion to 1000 record, so if we do a dot explain, we can see here the broadcast has join is applied because one is a very big table and another is a very small table. So internally broadcast has join be applied. So let's say another example would be when we have when does the broadcast nested join happens is is if it is a variant of a broadcast join where one of the datasets involved in the join operation contains nested data structure or something, if you could see here the equal sign or not equal sign, something like that. uh, that is what a broadcast nested join would mean. So let's say if I in my join condition, if I do greater than and then do a explain, and then here if you see my query execution, broadcast nested loop join is applied. So this is what broadcast nested loop join is. One table needs to be small, another should be big, and this should be a non-equi join. Then your broadcast nested join happens. So what is sort merge join? Sort merge join happens when your both tables are large enough, and then what sort merge would do is it would combine two sorted list of data into a single sorted list, commonly based on the key or condition that matches the criteria. So if we look at this another table, so this one is D1. This is also a very big table. So if we run this and then do a count, also let me run this table. This is running. Okay, cool. Okay, so now if we look at g1.count, so this one is something around 4 billion record. So if we do explain within these two tables, so both are big tables. So if we look at the join strategy, if you see it does a sort merge join because both are my big tables. So likewise, Cartesian join would mean it is a type of join operation where every row from one dataset is combined with every other row from another dataset. So something like if we do a non-equi join, so it would look at some the order ID greater than dt1 dot order ID, and if we do explain here, if you see a Cartesian product has been applied here. So this is how the internally if we see the the catalyst optimizer chooses the join strategy. So for best practices, avoid using non-equi join and try to optimize your code with equi joins when possible. So that's it for this video. Hope this video makes sense, and please like, subscribe, and encourage me to create more videos. Thank you.